In this video, we are going to understand about minor and cofactor of an element. Minor of an element. Minor of an element Aij of a determinant is obtained by deleting the ith row and jth column in which the element Aij lies. Suppose if you have a determinant, we need to ignore the row and the column in which it is contained in, and the rest of the element has to be considered. Sometimes if it is a 2 by 2 matrix, then the rest of the part will be an element. If it is a 3 by 3 matrix, then it will be a set of elements. It itself will be a 2 by 2 matrix. So minor of Aij is denoted by Mij. Now cofactor. Cofactor of an element Aij is denoted by capital Aij and is defined by capital Aij is equal to minus 1 power I plus j times Mij. What is Mij? Mij stands for the minor of the element. Here again, if it is a 2 by 2 determinant, then you will have an element. If it is a 3 by 3 determinant, then we will have a 2 by 2 determinant itself to be computed. Now let us consider a 2 by 2 determinant and understand cofactor and minor. Then we will move on to a 3 by 3 determinant. Now I am going to do it through tabulation so that you will be able to observe the relationship between the minor and the cofactor. Now you see the elements are A, B, C and D. Now if I have to find the minor of this, then I will have to ignore the corresponding column and the corresponding row. So what am I left with? I will be left with only D. So let us see here. Yes, minor of Aij, which will be Mij, and cofactor of Aij is denoted by capital Aij. So I have generalized it and given there. So now it will be M11. As I discussed, M11 will be equal to, ignoring the corresponding row and the column, we get D as the value. Whereas if it is A11, it is minus 1 to the power of 1 plus 1, because as per the formula it is minus 1 to the power of I plus j. Here I and j are 1 each. So it is 1 plus 1 times D, which is equal to D. Whereas if you observe the next element, it is 1, 2. So what is 1, 2? It is the element B. So if we ignore the element B here, if you ignore the corresponding column and the row, then I am left with the element C. Yes, but here when it is cofactor, minus 1 to the power of 1 plus 2 times C. So minus 1 to the power of an odd power. So it is minus again. So minus C is the value. Now if you have to calculate the next one, what is that? C. What is the position for C? It is 2, 1. Again the sum will be a odd power, so you get a minus there. So let us see. M21 is equal to, if you ignore the corresponding row and the column, you get B. So it is B itself, whereas A21 is minus 1 to the power of 2 plus 1 into B. So it is minus B. Whereas the last element you get, if you ignore the row and the column, we get to be A. But then it is, the position is 2, 2. So 2 plus 2 is 4. So I get a positive effect of A. So what do you observe? M11 is D and A11 is also D. But M12 is C and A12 is minus C. M21 is B but A21 is minus B. Whereas M22 is A and A22 is also equal to A. So if you observe this tabulation, you will find that where the power is odd, you get a minus sign. So in the alternate positions, yes, in other words, I can say in alternate positions there is a negative sign appearing. Thus, we observe that the minors and the cofactors differ only in their sign, also only in the alternate positions. So we will have to be very careful when we are writing the minors and cofactors. Now you would have noticed that it's very simple when it is done in a 2 by 2 matrix. Let us do a 3 by 3 matrix and understand much better.